Hello developers, how are you all? So this is the second video of the series React in channel only, and I hope you all have enjoyed the first video of this series where I have shared the plan displayed in the screen, which is already displaying in the screen, shown the setup of React with build handler, went through the folder structure, went through the files inside the functions, right, where they have written the core functions, uh, the types, different types, informed you about one how it is actually better than npm, and also showed you how to give tailwind support to your react application. So if you haven't seen that video, first go and check out that. If you go to YouTube and write only code, you will get my channel at very first, and beside that go to the first video displayed. Okay, this is the informative video you should check. But what is today's agenda? Well, I have changed the plan a bit of this custom React. Ideally, what I have thought is, while learning about how JS and HTML work as JSX, then only I should show you the custom React comp. Okay, but there are some changes in that. Custom React is not that easy. It's a bit deeper, and I want that if you need that video, because again, most of the people who comes to learn from YouTube doesn't want that deep level of okay. They want that only the topics, only the concepts to be read. But that video itself will help you to know the JS, the JavaScript hold you have. But okay, if you want it, then comment down in this video. Uh, let's say custom React, and we will give a small demo of the custom React. So today let's start with how does JS and HTML work with JSX, combining JSX. What is diffing? What is reconciliation? Okay, yeah, let's start. And yes, of course, before that, why actually React is needed to build our applications. So first of all, React is a tool of or library of Facebook, built that is developed by Facebook developers. Okay, if you know that most of the meta applications are built on React. Uh, why React is needed? For that, let's take a simple example. So suppose you have an application that you want to build, and there is a sidebar which will show you the user list. Then we have a chat section. In any of the users, you will click from the sidebar. That user's chat section will be opened in this page, in this area. Okay, this is the section for that. Here is a navigation bar where you can see the total number of chats that is been 100, and a profile section. That's good. Okay. So if you will see properly, we have lots of functionalities, like we can click on the different users and different users chat section will open. We can click on this chat area to check the new notifications. We can click on the profile area that will give us a pop-up of a square that will give you the different options of profile. Okay, this can be the case whatever you need in your application, right? This small things, on clicking of small things going back, is changing the pages or the components itself. Now you know, if you had done this with vanilla JS, HTML and CSS, then actually it would be a problem writing so much of DOM codes. With DOM manipulations, doing this much small changes would be a hectic thing. And there are chances that some of the times you would actually re-render the page or refresh the page just for the normal page, just for that small changes, or redirect the page. And hence React comes into the life of coders. Facebook, while making React, or the developers while making React, has confirmed that these small changes would be applied with minimal code changes. Okay, and with minimal operations. How that minimal operations actually work, we will get to know in today's video. But as for now, you know why React. Now, the second question comes, how JSX actually work. For that, if you know that if you have seen my previous video, this is a code, JSX code, where app is a component itself. Why it's a component? Because it looks like a function, but it returns a HTML document. Okay, that's a component. Okay, cool. So how this is actually work? Whenever you build your project, you write codes, the JSX codes, and you build your project. The browser only knows JavaScript, HTML, and CSS. They don't know this much of codes, JSX codes. So how things actually work? Well, we have something called Babel. Babel is a tool that has been used to parse the code of written in React, that is JSX codes, in JS objects. And I will give you the simple example of that. How this JSX will be converted to JS objects. Okay, that is parse it to JS objects, and how must be should look like. Okay, this is the parsing part. So see, let's focus on this part and this part. Okay, let me bring this here. Okay, how this parsing part actually works. So if you will see that in the function app we have something called fragment as the upper HTML tag. Okay, so that fragment is named as identifier. So every tag will be named as identifier, and inside that fragment, if you would have any of the children tags, then that would go inside the children tag. Okay, cool. Sorry, children flag or the variable. That variable must be array of objects, because again there are chances that there will be only one children, but there here we have two children, the h1 and the a tag, right? So here we have two children, so it will have consists of two html tags, that is, sorry, two objects in that array of the children array. Good. Then what more can we see? We can see that every tag, means not every tag, but the tags are like can be self-closed or can be closed later on. Like this fragment tag is been closed after enclosing the HTML tags inside it. Then again h1 tag is been closed after writing hello world. But if you see this a tag itself is been self-closed. So this is the self-closed, right? So as see, this is the assumption. We know that a Babel parse the JSX codes to the JS objects, but we can't write that robust of an object to and show you. It will be a hectic. So I am showing that how it must be parsed or how developers have thought. Okay, so they have got a condition of self closing and the closing later on. So what I have done is that we have maintained self close variable, and we will write true or false simply. The parser would do true or false. Okay, now again if you will come to this fragment, you would see that here is an attribute key, which value is math.random, right? So again this is the identifier, and that identifier's object has been closed at here. So the attribute flag is always also passed that variable, and inside that I have given that is key, sorry, key value pairs, right? So attribute is the key, and inside that I have given label key, because name is key itself, and then value is math.random. So math.random is the value, so given in the value part, right? Good. So this is the way that Babel actually parse the JSX object to the JS object. This is the initial flow. What happens after that? Then then there is again a Babel parser. One more parser is there that would actually do a call function thing. Okay, so what's a call function? Let me show you. We have something called create element, right? This is the function. Let's fix this arrow. So create element is a function. What it will do is whenever create element would be called, with an identifier like thing and give pass and given attributes for them, the create element will make the HTML element out of it. So now after parsing the JS objects, the Babel will again traverse to the JS object, right? And we'll go to write the call the create element part, create element function. But this create element is not directly be called. How this will be called? That this so what happens is the second parser, in case of the identifier, in case of the identifier, they will also attach a signature here of call function. Okay, so they will replace or attach here a call function. What that call function will do, that call function will itself call the create element, and then the create element is going to create a HTML tag for us by checking the attributes, by checking the self close and all. But why we need a call function right there? Because see, in the object, if you'll see, then we have identifiers, we have self close, we have attributes. So we have lots, 3 to 4 flags before creating of an element, HTML element. We need to check 3 to 4 different variables, right? So hence, before calling the create element, we need to check for all the requirements. So for that, we need a call function. And when the call function is been done, the parsing is done into the object, then the create element will be called in that call functions with respect to that call functions. Okay. So this is the way JSX actually work in the browser. Okay, the React codes actually work in the browser because browser always knows vanilla JS, CSS, and HTML. They don't know JSX. Okay, if you will open DevTools, that is Control Shift I of your keyboard, you will not be able to see any JSX thing. You will see the HTML element things, class names maybe, yeah, class names, styling differently, and JS, that is JavaScript, different. Okay, attached to each node. Cool. So now you know how JSX actually work. But here is the question: we need to know that actual flow, right? So what's the actual flow? Does I mean? That's what I mean with actual flow. Actual flow of React. How does it change or manipulate, no, change UI whenever we click or do anything in application efficiently? How does this happen? Now let's make it big. Should be big, right? And its color should be different. Its color should be big. Yes. So the question is actual flow of React. How does it change UI? That is, it will show in application, right? We are running, and whenever we click or do anything in application efficiently, right? Okay, so for before diving into this, let's dive what is actually a DOM. I know that you know DOM, but here we need to know some more things. Okay, so DOM is document object model. What is document object model? Whatever HTML tags you write for your application, that tags will be passed by the browser itself. Okay, the V8 engine to the tree like structure. So this is a tree like structure. Okay, to the tree like structure, and that tree like structure would contain the elements itself. So suppose if you have a div, and inside that you have a div and tag, and then a span tag, a tag, sorry, then you would observe the tree like this. And then again, if inside that div tag you would have again a p tag and a tag, then you would like, it means, then structure would be like this. But this is the DOM, this is the real DOM, browser make. But we have something called virtual DOM. What's a virtual DOM? See, virtual DOM is basically the lightweight of real DOM, right? So this is the virtual DOM. I have not given that circle so that you would think that this is a lightweight. Okay, so this is a lightweight of real DOM. What's a real DOM? When you make a tree-like structure and inside that you would have styling and JavaScript attached to each nodes required. But what should be the virtual DOM? Virtual DOM will be a lightweight DOM that is only kept for the comparisons. What kind of comparisons? I will tell you later on. For addition, if I am saying it's a virtual DOM and it's a lightweight, then there must be cases like this div element will not be present here, but the signature will be present of div. That will be like in string or anything else. Okay, this a tag will itself not be present like the real DOM, but the signature. So hence it's called a virtual DOM, and it's a lightweight. Okay, cool. So let me write here what is virtual DOM. Lightweight DOM React maintains. Okay, to for diffing. For diffing. What is diffing? For knowing the diffing algorithm or the flow, you would have to know the flow itself. Okay, and I am going to explain the flow. So what happens is, let's go to the dashboard. See, suppose this is not here, and you would click on the profile part of this application. What happens there? This square should come that would have different options of the profile. Cool. These options would be inserted in the DOM. This dialog box should be inserted in the real DOM. But what do you think? How actually React works? How they insert this? For that, what they actually do is on every click or any counter thing or any JavaScript is running inside that, and if any changes are should be done in the UI itself, then they are not going to manipulate the real DOM from start. Okay, they are not going to manipulate the real DOM from the start. What they are going to do is they would create a new virtual DOM. That is, if I have clicked that profile section, and that profile section would open a dialog box, right? So that dialog box would be inserted in the new virtual DOM, right? What does that mean? It means that if this is your virtual DOM, let's copy it. Okay, so now this is a new virtual DOM, and instead of div I want span. Okay, so this is your new virtual DOM, this is your older virtual DOM. What React will do, they will compare both of them, and if React will check that, means if React will observe that is there any difference or not, if it exists, then it will replace it with new virtual DOM, otherwise it will not replace. Okay, so as you know that we have a new virtual DOM and we have some changes also. So this virtual DOM, suppose you have a tag, right, with the name, and that profile section would, okay, cool. But how does virtual DOM will show the changes in UI? Because it didn't change the real DOM till now. This is the in this node we have div, but the virtual DOM itself got changed. So the diffing algorithm works this much only. Okay, what it actually do is it will change the DOM part. Okay, diffing algorithm is used to detect the change in new virtual DOM, and uh, if it exists, then the older virtual DOM will be replaced, right? Cool. Let me correct this indentations. Yes. So this is the part of diffing. Then again a trigger will happen in the React, and something called minimal changes apply to original DOM will act. that minimal changes apply. So the architect flow works like this. After the diffing part, the minimal changes apply will work. What it will do is, it will compare the original DOM with the lightweight virtual DOM. And wherever it will find the simple change, that is, sorry, wherever it will find a change, it will simply change that node. It is not going to change the whole page itself, but that node will be changed. So if you will take the example of our means we have taken here, we have changed the span tag right in the virtual DOM. Now these two of the virtual DOMs will be compared by React algorithm, and then the div tag will be replaced with span tag. Okay, none of the other nodes will be changed, only this node will be changed, and hence this is called the minimum changes applied to original DOM in React. This whole thing making of virtual DOM diffing and the minimal changes apply after a trigger in the UI is called reconciliation. Okay, so what is reconciliation? The changes apply in UI flow. The whole flow of the UI change applying. Okay, that's the reconciliation. And hence, you know how what is the actual flow of React? How does any trigger on click events change in the UI? What is the flow of that? We have something called React Fiber. Okay, so React Fiber is a part of reconciliation only. React Fiber architect is like having extra features like batching, how to maintain states properly, some extra features of optimization level, but these are the deeper level parts. We will discuss it as we will start with coding. Okay, like in use state is a hook that would very much dependent with batching algorithm. So we will learn that this batching with that use state. Okay, but I hope things are clear, and if it's not, then please revisit this video and play it once more, and you would get these things. This is a new thing, so you will so it's a bit of hectic, overwhelming, I know. Yeah, so that's it for today's video. We will meet in next video. Thank you, bye.